For section 12.5, we are moving on from just finding those lines of best fit to actually using them to help us make predictions about the data that we have collected. Example 12.13, data are collected on the relationship between the number of hours per week practicing a musical instrument and the scores on a math test. The line of best fit is y equals 72.5 plus 2.8x. What would you predict that the score on a math test would be for a student who practices a musical instrument 5 hours a week? So to do that, we need to understand this equation is giving us the relationship between the number of hours spent practicing per week right here, and that would be our x variable, and then the scores on a math test, and that would be our y variable. So our equation, y, which remember stands for the score on the math test, equals 72.5 plus 2.8 times x, and remember x is the number of hours practicing, and we are told in this case that that is going to be 5. So once you have that formula set up, that equation set up, all you have to do is type that into your calculator, 72.5 plus 2.8 times 5, and we get 86.5. So our estimate of the score of a person who would practice their musical instrument 5 hours per week, our estimate for their score on a math test would be 86.5 based on this equation. Now, obviously in our minds, there might not be any direct relation between practicing the musical instrument and score on a math test, but based on the data they collected, they did come up with a correlation, and so that would be our estimate based on that equation and that information that was given to us. One thing we do want to pay attention to, sometimes when we're given these equations, sometimes we are given the y value and sometimes we are given the x value. So it's important that you pay attention to which piece of information that you're given when you're working on those equations and doing those predictions. Now you may remember, or you may not, the process of predicting inside the observed values within the data is called interpolation. We actually talked about that way back probably in Unit 2, I would guess. But interpolation is where we're making predictions inside those values of the observed data. Then we have extrapolation, and that is the process of predicting outside of the observed values of the data, and that is called extrapolation. So those are our two types. So if we have data and it's giving us information, let's say between, let's use our last example, between 0 and 20 hours of practicing, and we're trying to predict that 5 hours like we just did, that would be interpolation. On the other hand, if we were trying to predict something outside of that range of numbers that we were given, then that would be extrapolation. And here's an example dealing with that. Example 12.14. Find the predicted score on a math test for a student that practices a musical instrument 150 hours per week. Is this interpolation or extrapolation? Why, and explain. So first of all, our equation, y equals 72.5 plus 2.8 times x, and the x in this case is that 150 hours per week of practicing the musical instrument. And when we plug this into our calculator, 72.5 plus 2.8 times 150, we get y equals 492.5. So that would be our prediction based on our equation. Now, there's a couple things that we want to think about here. Is this interpolation or extrapolation? Well, this one is definitely extrapolation for a couple of reasons. My guess is that they didn't observe anybody practicing 150 hours a week, because I took the time to look this up, and there are only 168 hours in a week. And it doesn't seem very reasonable that they observe somebody practicing 150 out of those 168 hours and use that information in their data set, because that only leaves 18 hours for eating and sleeping and traveling, and in this case, evidently they're still in a math class, so going to school and things like that. So this would definitely be extrapolation, because this value pretty much guaranteed was not observed by the people who were doing this research and getting this data. So that would be our reasoning for knowing that that is extrapolation. It's not because of the example that I gave from 0 to 20 hours or whatever I said. It's because that's just not really a realistic number. The other thing is, and we don't know this for sure, but if this was a percentage, obviously getting a 492.5% on a math test is something that is not going to happen also. Now, if it's a raw data score, then that's a possibility. But, well, that's our reasoning. That is the end of section 12.5. Pretty straightforward, just using the formulas that we would have come up with in the previous lessons and those lines of regression. Again, the one thing to make sure of is that you are careful whether you are given the X information or whether you are given the Y information as you plug in those values into your equation.